This is our second review unit. We're still going to look at connections into algebra. And our first lesson is variables in algebra. So our essential understanding is that students will be able to evaluate variable expressions. All right, so let's just start with a little bit of vocabulary here. We got quite a bit, so let's break it down. Of course, I hope you guys know that when a letter is used to represent a number, or sometimes a range of numbers, it's called a variable. So thinking about easy level 1 questions to go on the left, we might include what is a variable. So different examples of variables, of course, you guys have seen X, the most famous. But we could use A, we could use C, we could use just about any letter that we want to represent any number. Usually it represents a number that we don't know. So variables can take on different values. So for example, if we have the expression 5c, like you do right here, c could take on lots of different values. It could take on the value of 4, 7, 20, maybe negative, 3/2. It could take on lots of different values in that entire expression. So we have a lot to talk about here when we talk about variable expressions. So you guys have heard me tell you that language is really important, so it's really important to understand the difference between an expression and an equation. So today we're going to focus on expressions. So a variable expression is made up of the following things. First of all, it might have constants in it. So remember, constants are just any real number. So 2 might be a constant. 3/2 might be a constant. The square root of 7 might be a constant. -4 might be a constant. All of these are examples of real numbers, and constants may be a part of our variable expression. Variables. Well, we know what those are. Those are letters representing a changing quantity. So again, that might be X, A, C, F. I mean, it could be just about anything. Operations. Now, our 4 main operations are add, subtract, multiply, and divide. But we might see some other operations in our expressions as well, like we might see exponents. Of course, they're really just multiplication. So these are our 4 main operations: add, subtract, multiply, and divide. Those are going to be part of our expression. Then we have terms. Terms are always separated by pluses and minuses, or addition and subtraction, not by multiplication or division. So pay really close attention to this, and then we'll look at some examples of how to determine what the terms are. And then our last one is a coefficient. Now, coefficients are what we call numerical factors of a variable term. So for example, if we had the term 3x, then 3 is the coefficient. Okay, it's the factor. It's what we multiply the variable by. So we might want to write that down. It's what we multiply my variable by. That's a coefficient. All right, fantastic. So let's do a couple of examples. Let's identify the variable, the terms, and the coefficient. So in this first one we have 16y. So obviously the variable is y. There is only one term because we don't have any addition or subtraction. So 16y is the term. The coefficient is what we're multiplying the variable by. So the coefficient is 16. Let's look at the next one. We have 3x plus 4. This time my variable is x. This time we have 2 terms, right? We have 2 things separated by addition. So 3x is one of the terms, and 4 is the other term. The coefficient, when I multiply the variable by, is 3. All right, let's look at the next one here. F plus 3. All right, this time my variable is f. There are 2 terms, f and 3, separated by addition again. And my coefficient, Well, what is f really secretly being multiplied by? F is just like 1 times f. So my coefficient here is 1. And let's look at the last example. We have 13 minus k. So k is my variable. The two terms are 13, and since I'm subtracting k, oftentimes I'll think of that other term as negative k. And another way to think about that is the coefficient of k would be negative 1 because I'm subtracting k. It's like adding negative 1 times k. Great. So when we want to evaluate a variable expression, this is a really important word here, evaluate. In fact, let's even go an aside here. What word do we see inside the word evaluate? Value. So a great way to remember evaluate is find the value of. That's what it means to evaluate. So to evaluate a variable expression, we're going to start by writing the expression, substituting in a number for the variable, and then simplifying the expression. The result is, of course, the value of the expression. So if we want to simplify this down here, we write the expression, we substitute in our numbers, and then we simplify. So let's do an example. Let's evaluate the variable expression when y equals 3. So we write the expression, we substitute in the number, so 4y means 4 times y, so if we substitute in, it would be 4 times 3. And to simplify, it would be 12. So the value of 4y when y equals 3 is 12. In the next expression, we have 12 divided by y. So if we substitute, it would be 12 divided by 3. And if we simplify, we would get 4. So the value of 12 divided by y when y equals 3 is 4. And then in my last expression, we have the expression y plus 5. So if I substitute in my value, we'd have 3 substituted in for y, 3 plus 5, simplify that, and we get 8. So these are pretty simple expressions. One more here, 13 minus y would be 13 minus 3, and simplify that, and we would get 10. It just shows you the idea of plugging in your value. That's what it means to evaluate an expression. All right, sometimes we need to use formulas in algebra. So we're going to talk about 3 really common formulas today. The first one relates distance, rate, and time. And a lot of times we call this the DIRT formula. We don't really spell it D-I-R-T. We really spell it DIRT because the formula is distance equals rate times time, or DIRT. All right, so that's one way you can remember this formula. So the distance that you travel is equal to the rate that you go times the time that you spent traveling. Okay, so we're going to do an example using the distance formula here in just a second. But I want to talk a minute about units. So distance can be in all sorts of units. It might be in meters, it might be in miles, it might even be in inches. But look for some sort of unit that represents length. Time, that's usually pretty easy to identify. Seconds, it might be in minutes, it might be in hours. And so time is usually easy to identify. Rate is sometimes more difficult to identify, but here's a clue. Look for the word per, or something that means the word per. So for example, if we wrote MPH, what does that stand for? Miles per hour. So if we see that word per, we know we're talking about a rate. Another way we might see it is with a dash. So if you see something like this, M-S, that actually means meters per second. So look for that word per. That's a good indicator that what you're looking at is a rate. Let's do an example. Okay, let's find the distance D traveled in 2 hours of a race car that's going an average speed of 180 miles per hour. So again, simple example to illustrate the process that we're going to use. So we're going to start by writing the formula. Alright, so I got it right here. My formula is distance equals rate times time. Now we're going to substitute in our values. If we have 2 hours, that's clearly a time value, and 180 miles per hour. We see that word per, so that has to be a rate. So we want the distance. We know that the rate is 180 miles per hour, and we're going to multiply that by the time, which is 2. Now we simplify. 180 times 2 is 360. And now think about what units our distance should be in. Since our rate was in miles per hour, and distance has to be a length, my distance has to be 360 miles. And there we go. Okay, 2 more formulas that I hope that you're familiar with. If not, remember them now. And the first one is the perimeter of the triangle. So if we had a triangle whose sides were A, B, and C, the perimeter is just equal to A plus B plus C. So in other words, to find the perimeter, all you do is add up all the sides. But this gives you kind of a nice formula for it. The formula, of course, doesn't mean anything without knowing that A, B, and C represent the sides, so a picture is really important to go along with that formula. My second formula is for the area of a triangle. So to find the area, we say it's 1/2 the base times the height. Remember, the base can actually be any side, but the height has to be perpendicular, or in other words, has to form a 90-degree angle with the base. So just remember that relationship when trying to figure out what your base and height are of a triangle. So let's use these 2 formulas in 2 more examples. My next example is to find the perimeter of this triangle. We see that A is 8, B is 12, and C is 15. So just to illustrate the process here, we're going to start by writing down the formula. We said that perimeter is equal to the side A plus the side B plus the side C. Now we'll substitute in our values. Side A was 8, side B was 12, and side C, whoops, side C wasn't C, side C was 15. Now we will simplify. I know that 8 plus 12 is 20, and 20 plus 15 is 35. So my perimeter of this triangle has to be 35. All right, one more final example. Let's estimate the area of the state of Virginia. So the state of Virginia is over there on the East Coast, and right now we don't have enough information to estimate its area. But let's take a look at some distances here. So I'm going to draw a triangle because the state of Virginia kind of looks like a triangle. And again, we are just estimating its area here. I can see the base is 410, and the height, even though it's written over here, is the same as the height drawn here at a 90-degree angle. The height is about 20 miles. All right, so actually 200 miles, sorry, not 20 miles. The base is 410 miles. The height is 200 miles. So let's start with our process. Area equals 1/2 base times height. So here's my variable expression, 1/2 base times height. So now what we're going to do is evaluate that expression by substituting in the values of my variables. So my area is going to equal 1/2 times the base, which is 410, times the height, which is 200. And so now we'll simplify. I'll do my multiplication and division in order from left to right. So 1/2 of 210 is 205. And we still need to simplify a little bit more. So 205 times 200 is going to be a total of 41,000 square miles. And it's square miles because it's an area. And that is a good estimation of the area of the state of Virginia. So that's it for this first introduction to variables in algebra. Make sure you get all the left-hand column questions in and a 2 to 4 sentence summary your summary should certainly talk about evaluating your variables, and it should also discuss the different terms that we talked about in evaluating.